Now we're going to work on the last topic in Surds before we move on to indices or powers, which are very closely related. So I like to do them both together. And what we need to do is something called rationalising the denominator. Okay, let's take a look at our calculators to start with. If I type into my calculator something like this, 1 over the square root of 2, the calculator will change it to the square root of 2 over 2. If I ever type a fraction with a square root on the bottom, the calculator will always change it so that the square root is on the top. Now, two questions. One, why do we do that? And two, how do we do that without using the calculator? So 1 over the square root of 2 is the same as the square root over 2. And this is called a fraction with a rationalised denominator. It means that the bottom number is not an irrational number, is an element of our rational numbers, an element of Q. So we do this, we write surd fractions with rational denominators because of communication, because we want to be consistent. We want everyone's answers in the same format. The same way you wouldn't leave an answer as 4 over 8, you'd always change that to a half. We wouldn't leave an answer as 1 over the square root of 2. We'll always change it to root 2 over 2. So that's the why. Now, what about the how? So how do we do that? You might remember from algebraic fractions that you can multiply or divide the same thing on top of a fraction as on the bottom of a fraction. So, for example, let's put it up here for a second to show you. If I have 2/3, if I multiply the top by 3 and get 6, and multiply the bottom by 3 and get 9, that's an equivalent fraction. So I can multiply the top and bottom of a fraction by the same thing without changing its value. So here we're asked to rationalize the denominator, rationalize the denominators of the following surds. Let's start with the one that we have seen already, 1 over the square root of 2. And we'll do a few more as well. 2 over the square root of 3. 5 over the square root of 5. It's very, very simple to do this. Basically, all you do is you multiply the top and the bottom by the surd that's on the bottom. So if we look at the first one, I've got 1 over the square root of 2, and I'm going to multiply by the square root of 2 over the square root of 2. And the reason I can do that is because this is just 1. Anything over itself is just 1. And when you multiply by 1, you don't change the value. So that's going to give me 1 times the square root of 2 on top. And on the bottom, root 2 by root 2 is the square root of 2 by 2, the square root of 4. But the square root of 4, of course, is just 2. And that's exactly what our calculator was showing us earlier. So we've rationalized the denominator. We don't mind that there's a surd in the numerator. We only care that the bottom number doesn't have a surd. Part 2 then, we want to rationalize the denominator of 2 over the square root of 3. So we're going to multiply the top by the square root of 3, and we're going to multiply the bottom by the square root of 3. So I've got 2 times the square root of 3 on top, and root 3 by root 3, which is root 9, on the bottom. So that's 2 root 3 over 3. And that's it. Let's do the third one. You can pause the video and try it yourself before I show the answer if you want to see if you get it. And we've got 5 over the square root of 5. We're going to multiply the top and the bottom by this number here, root 5 over root 5. That gives me 5 root 5 on top and the square root of 25 on the bottom, which simplifies to 5 root 5 on top, 5 on the bottom. But there's more simplifying we can do now. 5 divides into 5. And my final answer here is just the square root of 5. And the great thing about these is that you can use the calculator. So unlike algebra, surds do go into the calculator, so you can always check your answers. Okay, I'm going to stop there for today. That's the last thing I wanted to do on surds. I'm not going to give us a test in this on its own because I want to do indices first. So we'll move on to indices from tomorrow after we've corrected the homework. Okay, thank you.